Hello. I'm Miles Tails per hour. We will learn about inertial and non-inertial reference frames. Firstly, I'll tell you what is inertia. Inertia is the property of matter in which an object that is at rest wants to remain at rest, and an object that is moving wants to remain moving in a straight line unless another force acts upon it. Suppose you are the viewer inside the train. You can see everything is moving outside with respect to its ground. Inertial reference frames are often used in general relativity and special relativity to describe relative motion of observers or objects and the effects they will endure. You would believe that it's a relative velocity for both trains or cars. Suppose, in another example, when you are sitting in a car, you would see another car moving in same direction with respect to your car. Its velocity could be almost same. That means, the relative velocity is almost zero. But if the relative velocity is equal to zero, its direction and velocity will be the same. If the car has flipped into that direction, its speed will now be added. Thus the relative velocity is non-zero, or it's roughly double velocity. These are just two cases for the relative velocity. Let's consider any two values of velocity, 8 and 10 meters per second. If the direction is same, then this gives a difference of 2 meters per second. On the other hand, if the direction is opposite, then this can be added to 18 meters per second. This is what the relative velocity plays a role, depending on its directions. On the other hand, non-inertial reference frame is a frame of reference that is undergoing acceleration with respect to an inertial frame. For the turning effect, suppose you're sitting on a merry-go-round, its objects are accelerating to each other. You can try using an activity, have a GoPro camera, to give it an inertial and non-inertial frames of reference. Like, comment, and subscribe now on YouTube.